Come back. This is grade 10 physical science paper 1 of November 2017. We are going to go through with you question 5. Okay, I'm just going to write here question 5. Okay, now first and foremost, let us start by reading the problem. They say a lift takes a man to a sky bridge which is 100 meters above the ground as shown below. He makes a bungee jump from the sky bridge and we're told to ignore the effects of air resistance. Now let us perform our analysis, guys. We are told that this guy is at the top of the sky bridge. So now this guy possesses what we call potential energy. Okay? And we know the equation for potential energy is mass times gravity times height. So now we need to keep that in mind when we start solving our problems. Now let us go to 5.1. Now in 5.1 they say define the term kinetic energy. Okay? A kinetic energy is the energy that is possessed by a moving object. Okay? It's an energy that is possessed by a moving object, guys. Okay? Now let us go to 5.2. They say the man and his gear have a mass of 72 kilograms. Calculate the gravitational potential energy of the man just before he jumps from the sky bridge. Now from our analysis, guys, you see we already have a clue of how to solve 5.2. We know that the potential energy is equal to mass times gravity times height. We are told the mass of the man is 72 kilograms, so we have 72. And we have 9.8 of which is gravitational acceleration times the height of which is 100. Okay? We just want to punch this into our calculator. We have 72 times 9.8 times the 100. Okay? This is 70,560 joules. Okay? This is the man's potential energy. Now in 5.3, guys, they say state the law of conservation of mechanical energy. Now the law of conservation of mechanical energy, okay, states that the sum of potential and kinetic energy in an isolated system remains constant. Okay, so now that is the conservation of mechanical energy. Okay, the sum of the potential and kinetic energy in an isolated system remains constant. Now let us go to 5.4. They say use the law in question 5.3 to calculate the velocity of the man at a height of 50 meters above the ground. Now if we were to represent this law mathematically, we are going to say potential energy plus kinetic energy at the top is equals to potential plus kinetic energy at the bottom. Okay, so now at the top, this man was at the sky bridge. We know that he had what we call the potential energy, so it's mgh. Okay, but now at that time he was not yet, he didn't make the bungee jump as yet, so now there's no kinetic energy. He only possesses potential energy, so it's plus 0. We don't have any kinetic energy. Now what he does now is that he displaces a distance of 50 meters. Okay, so now he still has what we call the potential energy. Okay, so it's gonna be potential energy, okay, plus now he's moving. He has displayed a distance of 50 meters. That means he also possesses what we call the kinetic energy. So this is going to be half of mv squared, okay, of which is the kinetic energy. Okay, so now we know that at the top we had the potential energy of 70,560, isn't it? After 50 meters we need to get his potential energy, of which is going to be his mass 72 times the gravitational acceleration times 50 is equals to half of mv squared. Okay, remember guys, we want the velocity of this man. Okay, now we are going to multiply both sides of the equation by 2 over 1. Okay, these will cancel out, so we're going to be left with mass times velocity squared is equals to twice of what we are going to get here, minus 72, 9.8 of 50. Okay, now we are going to divide both sides by m. Okay, now therefore v squared is equals to twice of what you're going to get, 72, 9.8 and 50. Now this is all over the mass of the man, of which we know that it's 72. Okay, now we are going to punch this into the calculator. Okay, now we're going to have 72 times 9.8 times 50. We have 35,280. So it's 2 of 70,560 minus 35,280 all over 72. Okay, we have 70,560 minus 35,280. Okay, then we're going to multiply this by 2. Okay, then we're going to divide it by 72. Okay, therefore v is equals to the square root of 980. Okay, and the square root of 980 gives us 31.3 meters per second. So that's the velocity of this man at a height of 50 meters. Okay, now let us go to 5.5. Now in 5.5 they say draw a graph of potential energy versus kinetic energy for the motion of the man from the instant he jumps until he reaches the ground. Remember guys, we said the potential energy and the kinetic energy in an isolated system will remain constant. So our graph is going to be a simple graph. Okay, we'll just label it here. Let me first indicate it. So we'll label here, this is the kinetic energy, this is the potential energy. And what you are going to have is just a nice closed graph because everything remains constant there. So we have this. Okay. So now guys, that is the answers to our question 5. Okay. We hope that we were helpful.